Hello YouTube, hello everybody. My name is Jaden. I'm a junior at UC San Diego, and thank you for joining me for kind of the first video of the series. So before we get started, I want to explain what the Power 25 is. So the Power 25 is basically sort of your roadmap, your foundational 25 LeetCode problems when you're on a time crunch, right? So, software engineering interviews, technical interviews, it's crazy. We have recruiting season right now, and there's 1,400 LeetCode problems, right? It's just not sustainable. There's a lot of kind of rabbit holes you can go down, and kind of you don't really know a roadmap to kind of study. So this Power 25 series will give you the 25 most essential questions. It's a curated list that I made that will give you a foundation of how to get started. So after these 25 problems, you should be able to approach really any problem you can in sort of a way, kind of knowing these past essential concepts. So these problems are kind of bread and butter to solving other problems, right? So cool, without further ado, we'll go get started with it. So first problem that we have is kind of number one of our Power 25 series is two-sum. So two-sum is probably one of the most asked problems in all of software engineering. It's kind of a bread and butter. You kind of need to know this. The like ratio is insane. So given an array of integer nums and an integer target, we're going to return indices of two numbers such that they add up to a target. So you may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So what do they mean by that? So example 1, we have nums is equal to 2, 7, 11, 15. Okay, so that's our array of numbers, and our target is equal to 9. We're going to output 0 and 1. Why? Because numbers of 0 plus numbers of 1 is equal to 9. So these are actually indices that we're returning of the array, not the values themselves. So the reason is because 2 plus 7 equals 9, so we would return the indices of the two values that add up to 9. Nums is equal to 3, 2, and 4 with the target of 6. We would return 1 and 2 because the indices of 2 and 4 are 1 and 2, which add up to 6. Numbers is equal to 3 and 3, and the target is 6. So the indices of the two numbers that add up to 6 are 0 and 1. Hopefully that makes sense. Now notice here we can see our constraints, kind of what our numbers are about to lie between. In an interview, it's very good to talk about kind of their constraints. What happens if a number is negative? What happens if the target is negative? And only one valid answer exists. So cool. So without further ado, we can kind of see how are we going to solve this problem. So I went ahead and made kind of my own example of how we would kind of do this using our own custom input and target. So a very naive solution is, okay, we have a target of 6 here, and we have to find two numbers that sum to 6. So a very straightforward naive approach would be, okay, we can start at the 2, and we can compare every single number to the right of the 2. And we can see if that adds up to 6. So 2 plus 7 is equal to 9. That's not 6. 2 plus 11 is 13. That's not 6. 2 plus 4 is 6. That's 6. We would return it like that, right? So that's very good, right? It would work. But you can kind of see how this is not as time efficient. The reason is because let's say the 4 wasn't here, and we're comparing all of these things, and then after that, we would sort of move our pointer using a double for loop, and then we would say, okay, we're going to compare 7 to 11, 7 to 4, 7 to 15. That wouldn't work. We're going to compare 11 to 4, 11 to 15. That wouldn't really work. We're going to compare 4 to 15. And you can kind of see how for every index, we're kind of iterating through all indices to the right of that index, which is actually O(n) squared time, which is actually very inefficient. And I will have another video explaining time complexity in future videos below, if anybody's interested. But yeah, it's just very inefficient. It's kind of not what we want here. You're going to get a time limit exceeded on LeetCode. So how are we going to kind of solve this problem, make this more efficient, and do this in one pass? So what does one pass means? It means we can just do this in one iteration. You see how I was doing multiple iterations? I was kind of comparing this, then I was comparing 7, 11, 4, 15, and then etc. We can do this in one iteration, one clean go through. And how are we going to do this? Well, we can use some data structures in our advantage. And what data structure can we use? Well, we can use a hash table. So what is a hash table? So a hash table is just a way of storing data for key value pairs that have very fast kind of lookup times. So why is this advantageous, you may ask, right? So what we can say is, let's analyze 2 and 6, okay? So let's say what happens. So 2 plus x is equal to 6. So how do we get to 6? We need a 4, right? So we can check if this hash table has a 4. Well, our hash table is empty right now. So what we're going to actually do is say, okay, well, our hash table is empty right now, so we can have this formula called our target minus our numbers of I that we're on. So in this case, it would be 6 minus 2 is kind of equal to the index of our first numbers of I. So that seems a little confusing. What do I mean by this? So 6 minus 2, right, because target is 6 and our nums I, let's say, is at 2 right now, is equal to 4. So since we don't, we're only working with the 2, we're only working with one number right now. So there's no way that two numbers can add to 6 because we're only on one number. So we need to say, okay, my lucky number is a 4. Let's see when I can find a 4 again. So we have this entry in the hash table of a 4. We're going to map it to our index that 2 is on. So this is going to be index 0, and say, okay, whenever we find a 4 in our hash table, well, what do we know? Whenever we find a 4 in our hash table, we know that we kind of found that lucky number, and we know that we can return both the indice that we're on in the numbers of I and the indice that was stored here. So this will make a bit more sense when we sort of iterate through these. So, okay, so definitely we don't see that. So let's go to the 7. So let's do the same exact formula. What's 6 minus 7 is negative 1. And negative 1 is not in our hash table. All we see is a 4. So if we find a lucky number, negative 1, in our other iterations to the right of this, then we know we found a match. But now there's no iteration. So negative 1 is not in our hash table. So we're going to put it in there and say, hey, if we find a negative 1, we're going to want to return this. Well, we have a 1 here. Okay, so now let's iterate to the 11. So the 11, what is 6 minus 11? It's negative 5. So is the negative 5 in the hash table? It's not, right? So we're going to say, hey, if we find a negative 5, we can add 11 plus negative 5 to get our 6. So this is going to be mapped to index 2. And now let's see here. So we go here, and we're going to say, okay, we're on our 4. Is 4 in our hash table? Well, it is. So what does that mean? 4 is kind of the lucky number that we were searching for. It's in our hash table. We found the 4. We found a match. So that means that when we were kind of doing our target minus numbers of I, we're searching for this 4, right? So since our 4 is in our hash table, we found a match. And what we can do is, hey, what index is 4 on? So 0, 1, 2, 3. This is kind of on index 3, right? And how do we get the first index of our first number that kind of created this entry, which is the 2? Well, we stored it in the hash table value here. So we can just access that value, and we can return both the index that we're on, which is I, and the value that is associated with this numbers of I. And this will be much clearer in the code walkthrough. And at the end of the day, we're going to return 0, 3, which is exactly what we want, and that is going to add to our 6, right? Because index 0 and index 3 is both going to add to 6. 2 plus 4 is equal to 6, and we're going to be all good and happy, and we're done. And if we don't kind of find anything, we'll just return negative 1, negative 1. So that was kind of the high level of walkthrough, and yeah, let's jump into the code implementation of this. So for the code implementation of this, we're going to do exactly kind of what we said, right? So first off, we're going to define a hash table. Right? And we can define it in many ways. I'm using Python, so this is just going to be a dictionary. We can just make curly brackets or make a dictionary object. And we're going to do exactly what we did in our kind of logic walkthrough. So we're going to iterate. So for I in range length of our numbers, we're going to say, okay, so if our numbers of I, right, is not in our hash table, right? So like if we don't find an entry, well, we need to map the entry. So these are the cases where, we do like 6 minus 7, that's negative 1. That's not in the hash table. So we just need to add the negative 1 into the hash table. So the hash table, of our targets minus nums of I is equal to I. And that's basically saying the target of 7 minus 6 is equal to I, which is 6 minus 7 is negative 1, and we're just going to map that to index 1, right? Because we want to kind of store the first state of where we found that sort of calculation. And then else, if it is in the hash table, well, we know that we're good. We found a certain matching, like how we found the 4 here. We know that we're fine because we found an entry that kind of says, hey, I need a 4, and then we found the 4 itself, right? So what do we have to do? Well, we would just return our hash table at our numbers of I, right? And I itself. And that's basically it. We would just return those two things, right? We're returning that, we're accessing this value in our hash table. And secondly, we're on the index, the current index that our pointer is on, right? So we're currently here, and we're accessing here. And boom, that would return everything. If the whole loop runs in the array and nothing gets returned, we would just return a simple -1, because we haven't found anything. And let's go ahead and submit the code and see what happens. And we got accepted. This is a very fast runtime here. It's actually O of n. I'll go into kind of more of why is it O of n, stuff like that later. And yeah, thank you guys so much. This is kind of my first video, so make sure if you're not liked and subscribed, you kind of subscribe to my channel. I plan to do this kind of regularly as soon as possible and kind of as much as I can, and all the support really helps. But thank you so much, guys, and have a great day.